Well, hi there. So in this video, we're going to take a look at the second type of monopolies, which are called natural monopolies. They're basically the same idea as an artificial monopoly, but there are some little tweaks that we're going to make. Before I get into any part of this, I just want to kind of draw a little picture up here and show you kind of what is actually going on with a lot of natural monopolies. If you can imagine that you've got maybe, for example, a marginal cost curve that looks like that and an ATC that comes down and looks like that. What if we took our marginal cost curve that looked like that and we just kind of stretched all the way out before we started coming back up again? And maybe we had an ATC that also came down and then hit its minimum and then came back up again, just like that. And imagine a type of firm where this would happen, where all of the demand for the firm's products, the demand, and then our marginal revenue that comes down from it, that all of the demand for this product could be satisfied within the downward sloping range of an average cost curve. In other words, where the firm is experiencing economies of scale. Now, there are some technical differences between what I'm actually going to talk to you about today in natural monopolies and the reality of them in an intermediate microeconomics class. For our purposes, we could just say what I'm telling you here is going to be okay, but some of it might actually not be 100% true. It's okay, don't worry about it. We're going to talk about basically these firms as if they exist in the short run, when in fact they actually only exist in the long run. But don't get too crazy and worry about that very much. It's not ever really going to come up. Now, these types of firms where they have this type of cost structure, where they could actually satisfy the demand for all the product in the downward sloping range of the cost curves, they do exist. They commonly operate as utilities. So, for example, an electric utility has huge upfront fixed costs. And basically, as they add each customer, the additional cost of a customer is actually going to fall, because once they've bought the truck to be able to drive to your house and climb up in the little boom and flip the switch to turn your power on, well, it's relatively cheap for them to go to the next house down the street and do the same thing. And in fact, as they add more customers, it spreads out their enormous fixed cost over more and more units. And so for the entire range for which demand exists for their product, electricity, they experience economies of scale. They have large upfront fixed cost, small marginal cost of adding a customer, and that's why they actually look this way. Now, we're going to draw what these look like here. Otherwise, aside from the shape of those cost curves, and it's really not the shape, it's just the range of the cost curve, they are exactly the same as the other types of monopolies. So you have a demand curve that tells you the price, you have a marginal revenue curve that comes down separated from it. And the way we're going to kind of draw this like downward sloping part is actually more like this. So we're going to put marginal cost on first. And now we're going to redraw that picture twice more, just to be able to set up like what does this actually kind of look like. So we have price and quantity. We're going to come down with a demand curve, separate out marginal revenue because it's a single price monopolist. And then again, we're drawing our marginal cost curve as kind of that downward slope. We don't want this MC to come back up again. We want to avoid that, because the downward slope of the cost curves throughout the entire range is what actually makes this a natural monopoly. So we don't want to see either one of the cost curves. Once we even put that average cost curve on there, we don't want to see it start to tick back upward again. So now that we've got our marginal cost, marginal revenue, and demand curves, we can actually identify the profit maximizing price and quantity. Now, we don't know the profit yet, right? We're going to have to put an ATC curve on there, but we can actually identify price and quantity without that right now. Let's go ahead and take care of that. Marginal cost equals marginal revenue is the quantity that they produce. So MR equals MC, the same as always, and they're going to go up to the demand curve to find the price. Piece of F, and then we're going to do the same thing again twice more. We're just basically setting up this picture. Right? We're setting it up, and then we're going to put our ATC on once we finish this step. So the first step is going to be draw demand marginal revenue, then put that marginal cost curve on, then determine the quantity, and then determine the price. So it is kind of a stepwise order that we like to do these things in. That way we don't forget any particular steps. So again, demand, marginal revenue, then marginal cost, then determine that quantity, then find that price. Now, the last step in drawing these correctly is going to be drawing them in profit, break even, or loss. Now, typically a natural monopoly would just earn profit ad infinitum. The other two pictures that are below this are going to be more like, well, if the firm's losing money or if the firm's breaking even. But there's no economic rationale for why this firm would break even aside from just a coincidence. So this is coincidental, right? Coincidence, not equilibrium state. Equilibrium state is a way to think about it, that they won't earn zero profit in an equilibrium like perfect competition. They could, in theory, just continue to earn profit forever and ever. So let's draw the profit rec one. Here we'll come down, ATC coming down, And I want to put my ATC below the price at the quantity that I'm producing at. So here, my ATC value, that's my ATC value. And the distance between these two is just the profit per unit, just like we looked at in perfect competition. And then we go over and we say that's our profit rectangle. Now for the next one, we need this kind of just a touch and then continue on. So ATC, just touching here and continuing on. And I have students who say, well, why is there no rectangle? Well, because they're breaking even. There's no loss and there's no profit. Silly goose. And then the last one, if they're losing money, then our ATC is going to be way up here, really high average cost. And at the quantity that we're producing at, that means our ATC is above the price. And so this is the loss per unit, that kind of highlighted area. And then if we go over, this amount is the total loss that this firm incurs. Okay, now the second part of the lesson today, aside from understanding natural, is understanding that monopolies are not efficient. And they're not efficient in two different ways. In one way, they are not efficient in terms of allocative, and they are also not productive efficient. So we're going to kind of talk about allocative efficient first, and then we'll come back to look at productive efficiency. Monopolies, because they profit maximize where MR equals MC as opposed to where the price equals MC. And remember, this kind of demand curve just tells us what the price is. That's the DARP. Because they're not producing this quantity, they are not allocative efficient. This is the same as saying they are not socially optimal. So you will sometimes see it described as socially optimal, or sometimes see it described as allocative efficient. And the precondition is that they are producing at the quantity where price equals marginal cost. That is to say, where demand equals marginal cost. But monopolies don't do that. They don't produce here, right? They don't produce here, they produce here at a much smaller quantity. And because of that, right, we can say this is the optimal. I'm just going to put optimal right here. We would have an optimal quantity, and then we would have an optimal price. And we can see just from this graph alone that the monopolist way overcharges and way underproduces. We are not producing a socially optimal quantity, so there's less total surplus actually than what would be in a competitive market. And as a result of that, there's deadweight loss. Deadweight loss, if you remember from the previous unit, was the lost value of transactions that would be occurring in an allocative efficient market, but because they're not producing the allocative efficient quantity, also known as the socially optimal quantity, then there is deadweight loss. And so we are going to want to kind of include that on here. Now the deadweight loss goes from, right, this is a kind of little part here, deadweight loss from the quantity that the firm is producing to the point where price equals marginal cost. And so it's kind of a level here where we say it's bounded by the marginal cost curve and the demand curve. It's the lost surplus. So this is the quantity we are producing. And it comes down along the bottom of that marginal cost curve because it's effectively like our supply curve, and it comes down along that demand curve. And so the area of deadweight loss here, put a little arrow, deadweight loss, looks like that. And again, we're kind of determining from the quantity the firm's producing, QF, all the way over to that socially optimal point where the price equals the marginal cost. It's going to be in the same spot on all three of these graphs. It comes down from the quantity the firm's producing, runs along the marginal cost curve, and then down here as well along the demand curve. And one last spot for it here, it's in the same spot right here, all the way down that demand curve, and then right above that marginal cost. And so it is the area kind of within these. So we have deadweight loss, and then we have the regular loss up here. Now, students will sometimes get kind of mixed up. They'll say, well, what is the difference? This is an actual economic loss. This is money or implicit opportunity costs that this company is losing. This is saying this is like lost surplus, that the society is not gaining from these transactions not happening. Because there are people who are willing and able to pay all along this demand curve. They're willing and able to pay prices that are higher than the cost of each individual unit. And so we would want those transactions to happen. In a competitive market, if you were willing and able to pay 12 and the marginal cost of a unit was 8, your transaction should happen because the cost of the unit was $8, you were willing to pay 12, you guys should meet and transact. But in this case, these people are not, right? There's this people who are willing and able to pay higher prices than their marginal costs, and they're not getting a transaction. And again, that's because this monopolist is actually profit maximizing using the marginal revenue curve rather than the demand curve. Now, the second part of this is going to be going back and shading our graphs in the previous artificial monopoly graphs. So let's take a look at what those look like, because we're going to find that deadweight loss in exactly that same spot on these graphs. It goes from the quantity that we are producing at QF, So I'm going to shade that kind of heavily. It goes up that marginal cost curve, and then it goes over. So again, deadweight loss is right there. It's a little bit easier to see it in this one. Again, the quantity that we're producing, pointing kind of toward what is that optimal point. And I'm going to go ahead and put right here a little point, then I go optimal. Right? That's the socially optimal or allocative efficient point. And then it's in the same spot on the very bottom one as well. You go from the quantity we're producing up that marginal cost and along that demand curve. And again, that's our deadweight loss, whereas this one is our economic loss. So it's, again, identifying where that deadweight loss is, but how we're able to do it is by noticing where is the optimal point. And the optimal point is where price or demand, if you want to say it that way, equals marginal cost. Now, the second type of inefficiency that actually these monopolists incur is called productive inefficiency. And this is the idea that they are not producing at the minimum of the average total cost curve. These firms, that is to say the natural monopolies, cannot, because the minimum doesn't occur within which the demand exists for their product. So natural monopolies are never productively efficient. We would actually say that they have lots of excess capacity. It's the difference between the amount that they are producing and the minimum point of the ATC, which is a way bigger amount. Now we can see that the other types of firms, artificial monopolies, are also not allocative or not productively efficient. This is our minimum point, minimum ATC. And that point right there is the productive efficient point. And you can see that we're not producing there either, right? We're not producing at minimum ATC. We're not producing here at the minimum ATC, right? So that's another productive efficiency point. And likewise here, we're not producing at the minimum ATC. So none of these firms are productively efficient because they are excess capacity. They could produce more units at a lower average total cost, but they're choosing not to, again, because they profit maximize where MR equals MC. So this walks you through the idea of natural monopolies, and we talked about the two different ways that monopolies are inefficient, both allocatively inefficient and productively efficient. Hopefully this helps you. I'll see you next time.